All right, so here's what we have. We have a skier, and she starts at the top of the hill and she goes zooming down. And it says that the skier has 6,000 joules of potential energy at the top of the hill, and they are not moving. What is their total energy? So remember, the total energy is equal to the kinetic energy plus the potential energy. And it just told us they are not moving. If they are not moving, they have no kinetic energy. So the total energy just equals the potential. And it told us there's 6,000 joules of potential, so the total energy must be 6,000 joules. All right? Now, we're going to assume they have special skis. They're frictionless, so we're not going to lose any energy. All right? So when they get down here to point B, what is their total energy going to be? Well, the big idea for this whole unit is that as she goes down the hill, her total energy never changes. So if her total energy is 6,000 joules at the top, her total energy anywhere is going to be 6,000 joules still. So right here at point B, her total energy is still 6,000 joules. Okay? Now, it says there's 3,600 joules of potential energy at point B. So, we know that her total energy must be her kinetic energy plus her potential energy. Her total energy we know is 6,000 joules. For this problem, for my numbers, that's going to be the same everywhere. That's got to equal her kinetic energy plus her potential, which is 3,600. So if we know her total is 6,000 and 3,600 of that is potential, then the rest must be kinetic. So to find the kinetic energy, we can subtract 3,600 from both sides, and that gives us a kinetic energy of 6,000 minus 3,600 is 2,400 joules. So we know she has 2,400 joules of kinetic energy. All right? Now, when we get to point C in the diagram, now we're down here now, it says she's 5 meters above the ground. And we want to know how much potential energy she has. Now, we know her total energy. It's going to be 6,000. That's never going to change. But what is her potential energy? Well, you're going to have to remember back potential energy is m times g times h. So we have to take her mass, which is 30 kilograms. We got to multiply it by g, which is gravity. Remember, that's 10. And we got to multiply it by height. It says she's 5 meters above the ground. So if we take 30 times 10, that's 300. 300 times 5 is 1,500 joules. So when at point C, she has 1,500 joules of potential energy. Okay, so we're just going to use m times g times h. Now, at point C, right here, we know her total energy is 6,000 because it never changes. And that's got to equal her potential energy, which we just found, plus her kinetic energy. And so, at point C, if her total energy is 6,000 and 1,500 is potential, then the rest is kinetic. So we can subtract 1,500 from both sides, and we can get that her kinetic energy, 6,000 minus 1,500, is 4,500. Her kinetic energy is 4,500 joules. All right, so we are just using the idea that total energy always stays the same. So if you know one of her energies, you can figure out the other one. All right, now when she gets to the bottom here, how much potential energy does she have? Well, remember, potential energy has to do with how high you are, right? It's m times g times h. And if you are at the bottom of the hill, h equals 0. So if you take the mass times 10 times 0, you will get 0. At the bottom of the hill, she has no potential energy. There's no energy stored in her height. So she has no potential energy. So if she has no potential energy, what is her kinetic energy? Well, we know her kinetic energy plus her potential energy have got to add up to the total energy, which for this problem is 6,000 joules. And if I told you there was no potential energy, then what must kinetic be? Well, if the kinetic plus the potential got to add up to 6,000 and there's no potential, then the kinetic energy must be 6,000 joules. At the bottom of the hill, all of her energy is kinetic. Okay? And the last one's just a little bit tricky. We know kinetic energy is 1/2 of her mass times her velocity squared. So if we want to find her velocity, we've got to put in her kinetic energy. So her kinetic energy is 6,000. That's going to equal 1/2 of her mass. Her mass was 30 times her velocity squared. So 1/2 of 30 is 15. So we are going to have 6,000 equals 15 times the velocity squared. So if we divide both sides by 15, we'll have the velocity squared. So I'm going to put that in my calculator. I'm going to take 6,000 divided by 15, and that's 400. So that tells me, I'm going to slide down a little bit here, that 400 equals the velocity squared, and then we take the square root to get rid of it, and that tells us the velocity is equal to 20. So the velocity is 20 meters per second. We can figure out how fast she's going at the bottom of the hill by using energy. Okay? You're going to solve almost an exact kind of problem for your homework, except you're going to have different numbers. So for your problem, she's going to start off with a different amount of energy. So you'll have to kind of work through this with a different amount of energy, but the ideas are exactly the same.